So the working model that we use, which we're still working it out, we're piecing it together, but we've got this model in our minds and in some of our theoretical calculations that seems to be working. And when I say working, we can tweak parameters that we think will tune how the device responds, and that's working. It's tuning it like we think it should. And what it's based on is the fact that we've got this glass, germanium selenide, Ge2Se3. Also, you'll see this as germanium 40, selenium 60, that has germanium-germanium bonds within this glass network. And those bonds are key to how this device operates. And what we're finding through the theoretical calculations, here's a couple of references here, is that as you start to first form this device, electrons actually in excess of what's normally there in the glass, if you inject electrons into the system, around these germanium-germanium bonds, you get self-trapped paired electrons and single electrons. And it's the paired electrons that are self-trapped that initiate a reaction. The germanium in this bond, one of them attached to selenium, breaks a bond with selenium, according to the calculations. And as it does, it opens the glass network a little bit. And then what happens, the tin from the tin selenide layer comes in, and it sees this favorable site. It goes in and it actually displaces a germanium atom and bonds to that germanium site. And then once it does that, silver is coming into the system. Now it sees this tin germanium bond. The energetics are such that it's very favorable to take that tin off and put the silver on, and it wouldn't do that normally. So this is kind of a metal-assisted reaction, if you will. But what we see here in the model is that this actually allows silver to get on germanium, creates an open structure, and creates silver agglomeration sites. So what we think is that our channel is essentially a self-directed channel through these germanium-germanium bonds, and it just changes resistance by the accumulation of silver within that channel that's formed. Silver will not go onto that germanium atom without this metal. It just isn't feasible. So in working with that, I'm going to get back to how we use that information to try and help us with devices, but I want to summarize this basic device structure and let you know that it does work at high temperature.